Hello everyone, hope everyone is doing well. Today we're going to talk about the normal distribution. We have all kind of heard about the normal distribution and we have seen what it looks like. So it is a bell-shaped distribution and it has some characteristics. We say that the normal distribution is actually a continuous distribution, and this means that it doesn't have any countable observations. So if we list all the numbers, maybe we may not be able to count every one of them. And this is different from a discrete distribution because in discrete distributions, we could count the number of observations we have and we could see their probabilities. In a continuous distribution, the numbers, each observation is so numerous that we may not be able to count the number of observations we have. Now, the shape of the normal distribution is known to us. We have seen it in many different places. It is a classic bell shape, which is like this. And we have the height, or the mode, is right in the middle. And we have a certain mu, which is my mean, and a certain standard deviation. So from here, we can see that the shape is kind of like a bell. It is symmetric. So some of the characteristics of a normal distribution are the normal distribution is symmetric around the. So what the symmetric mean is that if I put a mirror right here, if I put a mirror right here in the middle, then the left-hand side is a copy of the right-hand side. So they look exactly the same around the mean, or the left-hand side of the mean looks exactly like the right-hand side of the mean. The mean is given by the letter mu. It's a Greek letter mu. And the standard deviation is given by the letter sigma. Okay. Now, one of the things about the normal distribution that is unique is that for the normal distribution, the mean equals to the median, which equals to the mode. So since it is symmetric and the mean is right in the middle, so our letter mu, this is going to be the mean. So mu equals to the mean, which also equals to the median and also equals to the mode. And sigma is the standard deviation, so it tells us how spread out or how collapsed the data is. Now, if I have a much more, let's say this sigma is of a certain value. Let's just say for example purposes, this sigma that we have with the black line, this sigma equals 2. And the mean is, let's say, 5. Now, if I have another normal distribution, let's say the red one, where sigma equals 4, but mean is still equal to 5, then what I would see is the mode will be lower and the normal distribution would be a little more spread out. It's still symmetric. I mean, my diagram is kind of bad. My drawing is really bad, but it will be symmetric. It will just be the mode will be at a lower level. Same thing with if I reduce the standard deviation. So if standard deviation is, let's say, if I look at the green one where mean is still 5, but standard deviation is 0.5, which means a much tighter distribution. That means that the values would be kind of like that. So it means that now, so the standard deviation is telling us how spread out the data is from the mean. And we normally use standard or normal distribution when we have a lot of data and we are trying to figure out what to do with our another special normal distribution that we use a lot. This is called the standard normal distribution, where the mean is 0 and the standard deviation is 1. And this is normally given in books, in tables, and we use this one to find our probability. Sometimes we may have data of other normal distributions, so we use that to find our probabilities. We convert our numbers to the standard normal distribution, or the values within the standard normal distribution, and then use that to find probabilities. So let's look at some examples. At what times or in what cases do we use normal distribution? So in our case, for normal distribution, we normally use it to find probabilities, which means that supposing something is distributed normally, I may want to find what is the probability that the number is going to be, let's say, below a certain value. Or what is the probability that a certain number is going to be above a certain value? Or what is the probability a number is going to be in between a certain value? So we can look at other examples. So let us look at some example in Excel. Now there is a formula for normal distribution. I'm not putting it up here because it is kind of complicated. And there are ways to find the probabilities of a normal distribution using a table in the book. We are not going to use that. We're going to use our formulas given in Excel to find those. So let's look at this example. We are first going to look at it diagrammatically, like graphically, to see what exactly it's telling us. And then we will use Excel to find them. So let's say we have a normal distribution which has a mean of 50 and a standard deviation of 3. Now, if I have this, what is the probability that if I have a number and I randomly pick a number, that number will be less than 48? So we know that our mu, or mean, is 50, and my sigma, which is my standard deviation, is 3. So if I graphically draw this, so let's say if I graphically draw this, I have a normal distribution with a mean of 50 and a standard deviation of 3. Now in the first question, it's asking us, what is the probability that I pick a random number? This is all the numbers that we have in that distribution. If I randomly pick a number that is from this distribution, what is the probability it will be less than 48? So if this is my number, x is 48. So what is the probability that I will pick a number, maybe 45, 46, or maybe even 45.2, or some numbers in between? So we don't know exactly the number because the numbers are not discrete distribution, are part of a discrete distribution. You can have any number less than 48. So we are going to then basically, the shape is telling us kind of the probability. If you think about it, I mean, it's not really the case because the probability of a number, you getting one number, is almost close to 0 or almost 0, because imagine something like this. Supposing it's raining and you have a window. Now, if I say, what is the probability that a raindrop will fall exactly at this point? That is probably close to 0. That is what we are doing here. What is the probability that I'll pick exactly 45? That is very close to 0. But if I say, what is the probability that a raindrop will fall in this box right here? Now that has a probability. Let's say I shade it in blue. Now that has a higher probability. So this is what's happening here too. I mean, we cannot really say which exactly a number, but we can give a range. And the range here is less than 48. So all these numbers are possible. So because of that, we have, since the probability of any one number is pretty close to 0 or almost 0, what we are doing is we are adding all these probabilities. Then we get a number. So we are going to add all these probabilities up to and including 48. Now, because the probability is going to be the sum of these numbers, we can now find it. So one way of doing it is exactly like adding all those probabilities and finding that. So this shaded region is telling me what is the probability that x is less than 48. Less than or equal to doesn't make any difference because the probability of getting exactly 48 is close to 0 or almost is 0. So therefore, we are finding this region. Okay, now the next one is, what is the probability that the number I pick is going to be greater than 55? So if it's greater than 55, I go back up again here and I look at all the other numbers. So let's say 55 is here. Then I'm going to add all the numbers that are in this distribution that's greater than 55. So the probability would be basically the sum of all these lines that we have. So this region is going to be probability of x's greater than 55. And then if I were to find something in between, let's say the next probability is, what is the probability that a number I pick is between 49 and 52? So between 49 and 52, it would be, again, if I pick this number and here, so this is 49, that's 52, and then I basically am looking at all these numbers here. So now we can see visually what we are measuring. So 49. Now how are we going to find these numbers? We are going to use Excel, as I said before. Now what Excel does is that it measures the probability from left to right. So it always measures from the left-hand side. So whatever probability I find, let's say I want to find the probability of a number. Let's say find a number, probability x equals, let's say the value g. Okay, some value of g, or x is less than or equal to g. That's what Excel always finds. So what Excel does is, given any number, wherever g is, let's say if g is here, then they will find this region. On the other hand, if g is maybe here, then they will find basically the area or the probability of all these regions. So it always goes from left to right. So if I go back to this example here, I can see that, okay, for the first question, what is the probability that I pick a number that will be less than 48? So if I do that, if I draw my normal distribution here, I know it's not really the nicest normal distribution, but this will do. So this is my mean, mu equals 50. And I'm looking at a probability of less than 48, or x is less than 48. So I'm looking at this region. And it's always a good idea to draw it first and then calculate it. So for number 1, finding probability that x is less than 48. For that, we are going to use this formula, norm dot dist. Now the number is going to be 48, that's my x. The mean is given is 50. The standard deviation that I have is given is going to be 3. Cumulative, since we are adding all the probabilities, so we will say true. And then we press enter. So this is giving me what is the probability that the values are going to be less than 48. So there is a 25% probability, or 25.24% probability that I may pick a number that is less than 48. Now for the second one, the probability is, what is the probability that x is greater than 55? Now for that, I'm going to find, if I draw the graph, it's going to be here, as I said in a few moments ago. So it's going to be this region. Now we said that, Excel does not really find this region, but we know that the total probability equals 1. So the area of this whole region, no matter what the normal distribution is, the total probability equals 1. So what I can do is, I can find, Excel will give me this number, the blue region, which is going to be, so Excel will give me the area of this blue region, which will be the probability of the x, or the number, less than 55. So I can calculate this region, probability that x is less than 55. So if I want to find probability x is greater than 55, what I can do is, I can do 1 minus probability that x is less than 55, which basically includes 1 minus norm.dist. Let me just equals to 1 minus norm.dist. The x's mean is 55, or so the value is 55, mean is 50, standard deviation is 3, and for cumulative we will say it is true, and we get this number. From this statement we can say that there's a 4.78% probability that I pick a number that is greater than 55, so the number is in this red region right here. Now what about the third one, which is going to be what if it's between those two numbers? So again, let's draw our normal distribution, and so the number is going to be between 49 and 52. So for number 3, let's say the number is between here and here. So 49 and 52. What is the probability that the numbers are between, or that I pick a number between these two numbers? So that will be the area of this region. Now the thing is, we said that Excel always measures stuff from left to right, so I can find out the probability of, let's say, I can find area, so I can find the area of this region, which is the probability that x is less than 49. So if I were to find in the third one, what is the probability that the number I pick is between 49 and 52? So I know this region, which I need to subtract, but then also if I find the area of this region, which is x is greater than 52, or x is less than 52, sorry, and then I subtract the probability of x is less than 49, then I'm left with the probability that x is between 49 and 52. So what that means is, what I can do is probability of x is less than 52, that gives me that blue area, and I subtract probability that x is less than 49. That is the area of that black region that is kind of covered by the blue area. So if I have those two numbers, then now I can find this equals to norm.dist. X is going to be 52, the mean is 50, standard deviation is 3, and cumulative is true. And then I subtract norm.dist, 49, 50, 3, and true. And I get 0.378. So I can say that there is a 37.8% probability that I'll pick a number between 49 and 52. So let's look at a problem. So let's look at this problem. Let's say there's a company that produces chips in a bag, and each bag is supposed to have 40 chips. Just to make sure that there's a lot more bags with 40 chips, the company tries to make sure that the average chips in a bag is 42 with a standard deviation of 4. So if a bag has less than 37 chips, then it is thrown away. So we can find out then what proportion of the bags are thrown away. So if we draw our normal distribution here, so we have our mean is supposed to be 42, and any number where if the chips have less than 37, then it's thrown away. So we need to find this probability. So after we draw this, then we have probability that x is less than 37, which means that it will be norm.dist. So my x is 37, the mean is 42, standard deviation is 4, and my cumulative is true. So it is 10.56. So we would say then 10.56% of the bags are thrown away. Now, in business sense, this helps us to understand that like this is a huge amount that's wasted. So now we need to reduce this. So maybe then we need to figure out what else can we do to make sure that fewer bags are wasted. Maybe we need to either lower my standard deviation so that it's closer to the number 42. Most bags are closer to 42. Or we may have to, if we can't reduce our standard deviation, we may have to increase the mean of the bags of chips. So more chips are in a bag. So now this is like if given a number, we can find the standard deviation. Another term we said that finding the another thing that we may need to do is if we are given a probability, can we find the number? So let's say if we're looking at this example, let's say that. So let's look at this one, which says, okay, 10% of the bags of chips have greater than which value? So in that case, we are going to see, we don't know this number, but we know that this value, that the probability here is 10%. Now this is the number we need to find. So how do we do that? Well, we used norm.dist to find the probability so far. We are going to use something called norm.inv. So we are going to use equals to norm.inv. What's the probability? The probability is going to be 0.1 and mean and standard deviation. However, when I do this, if you notice, as I said, all the numbers always go from left to right. So this measurement is going to be from left all the way up to 90%. So what I need to find is the number equals to 1 minus norm.inv. The probability is going to be 0.1. The mean is 42. And the standard deviation is, so let us find this value. 10% of the bags of chips have greater than which value? So we already have this number. So we have the mean is 42 and the standard deviation is 4. So we have, this is my normal distribution. The mean is 42. Now we have to find which value, so 10% is greater than which value. So basically the 10% I'm looking for is here. I don't know what number this is, but this value is going to be 10%. Now, as we said for the example above, like, we need to, everything's measured from left to right. So basically, if this area is 10%, then the other side is going to be this whole area that we have. This area will be 90%. So the value where 10% of the chips have, or bags have greater value is the same as 90% of the chips have less than that value. So we are going to use the formula, another formula here, which is norm.inv. So what we will do is write equals to norm.inv. The probability is 0.90 because we're going from left to right. The mean is going to be 42 and the standard deviation is going to be 4. And we find it is 47.12. So we can just write 47. So 10% of the bags of chips have more than 47 chips. Now what if I wanted to find the same thing? 5% of the bags of chips have less than which value? So in that case, we would be looking at 5%. So maybe this number. And this is the region that we are looking at. So if this is the region we want to find, now we don't have to do any subtraction of the probabilities. We know exactly what it is. Let me actually copy this formula. So in that case, we would say What is the proportion? So it would be just equals to norm.inv. The probability is going to be 0.05. The mean is 42. Standard deviation is 4. And we find 5% of the bags of chips have less than 35.42. So we will say 5% of the bags of chips. So this helps us to then find out if I'm producing something, where should I be in my production? How much do I need to throw away? How much do I need to keep? Where am I overproducing? Where am I underproducing? And there are many other cases where we can use normal distribution. Hopefully this was beneficial, and I will. Now, another thing that we may have a list of data, and we may want to find out if this data has a normal distribution. So let's say we have this array of data, and we want to know, is this data normally distributed? So let's find the mean, and this is the formula for average, and the formula for standard deviation is, let's still use .s since we are still dealing with a sample. So here now, if I were to find out, is this normally distributed, one thing we would do is calculate the z-values. And we have done z-values before in a different video. Now a z-value, the formula is basically, I'll just write it here, z equals the value of x minus the mu divided by the sigma. So it's going to be basically the value is x that we have minus the average 9.1818 divided by the standard deviation, which is 4.578. And so after we obtain this z-value, we can copy this formula all the way down to the numbers down here. And then what we do is we arrange them in ascending order or descending order. So we can go insert, or we can go to data, sort, and I will sort column D from smallest to largest. And so after I sort them, I'm going to chart it. So I will insert and I will draw a line graph. And I see that it is somewhat of a straight line. If the line is straight, then we say that this data is normally distributed. So if the of z-values is straight, then we can say that this value or this data has some properties of a normal distribution. So this is how we normally find the normal distribution, and we use our data for that. Another way of doing it is converting the values to z-values and then finding the normal distribution. So I'm putting it at the end. So let's say that if I wanted to find what is the probability that the number I pick is less than 48. So in that case, what I can do is I can convert 48 to a z-value. So this is a separate thing. So you can use all the formulas we have given so far, but let's find it using the standard normal distribution table. So we convert the 48 to a z-value, which as we showed is equal to 48 minus 50, which is 48 minus the mean divided by the standard deviation, which is 3. So our z-value is going to be this number. And so what we would find is, so the probability that the z, or the other number that I pick, is going to be less than negative 0.06667. And this number will be equal to, what I will use is norm.s.dist. I will use the z-value, and again, since I'm going from left to right, so I'm fine with that. So all those other things are there. Or what I can do is I can just select this number, and I will say cumulative, it is true. and I get the same number as before. So 0.2524, which is the same as 0.2524. If I were to find this number, what is the probability that x is greater than 55? So I would convert x or 55 to a z-value, and that would be equals to 55 minus 50 divided by 3, and I get 1.667. And then I would use the same formula again. So let me actually copy this up to the side. So the formula would be the probability that z is going to be greater than 1.66667. That will be equals to norm.s.dist. The z is this value, and cumulative is true. And I get 0.9521, which again is from the left to right. So what I need to do is write 1 minus that. So it should be 1 minus the z-value, and I get that value. And so the same thing is if I had the probability between 49 and 52, I have to convert those two numbers to z-values. So 49 to z-value, it is going to be equals to 49 minus 50 divided by 3, and 52 to z-value is, we actually copy this to the side, it is that number. So here we have these two numbers, and now we have to find the probability that the value that you pick, that your value is between negative 0.3333 is greater than z, which is greater than 0.6667. And you would just do just what we did before, which is equals to norm.s.dist. The z-value is that, and cumulative is true, minus norm.s.dist, where the z-value is this value, and it is true. And we get 0.378. So if you need to find, if you're comfortable using z-values first and then finding the probabilities, you can do that. Or if not, you can go straight to the values, because Excel does it for you. Same thing with this. If I wanted to find what is the probability that the numbers are thrown away, before I could just plug it in. And now I can just do it the other way around. So basically, if I were to find what is the probability that, or at what number is 10% of the bags greater than some value is thrown away. So I found it was 47.12, and this is the formula. I can also use norm.s.inv. So if I do that, which is equal to norm.s.inv, the probability is 0.10. Actually, this is from left to right, so we have to do probability at 90%. So it's 1.28. Now this is the z-value given. So this is the z-value given. Now I have to solve it out. So I know that x minus the mean, which is 42, divided by the standard deviation, which is 4 for that example, this equals to 1.281. So what I need to do is now solve for it. So x will be equal to 4 times z plus mean. So which means it would be equal to 4 times the z-value plus the mean, which is going to be 42. And I get 47.124, which if I look at the number here, it is very close, 47.12, 47.124. If we rounded it up a little more, we probably would get the same number. So in that case, you could use either or, since norm.dist and norm.inv, to me, it seems a little easier, so I explain that more in depth than finding it through the standard normal table. But if you want to, you can use the other one too. Hopefully this was beneficial, and I will see you at a later lecture. Have a good day. Goodbye.